In my previous attempts at launching the rocket glider, most of the time we ended up falling over. I think this is because I got the stability wrong and the wing lift was pulling the whole vehicle backwards. The swing testing we did may also have been a little deceptive. I think it was actually testing the gliding ability, not launchability. And of course the rope counteracted the lift from the wings. Later I found this amazing Estes documentation about building boost gliders. Note they either have delta wings or put the rocket at the front of the vehicle instead of at the back. And when you work out the correct Google search terms, this becomes pretty obvious. Putting the engine at the front does not invalidate the pendulum fallacy. Pendulum theory states that if we use the nose of the rocket as a pivot, gravity can give us stability by pulling the rest of the body downwards, like a pendulum. However, this only works if the pivot point is fixed. During flight, gravity acts equally on every part of the rocket and will not change the orientation. Even very clever minds have fallen for this. Robert Goddard, often seen as the father of modern rocketry, did some of his first experiments of the rocket at the top for this very reason, as seen in this 1926 photo. So we need to build a new rocket, this time without fins and with a glider as far back as we can get it. Luckily, the Stratofin launcher that I am using comes with a standard tripod bush, so we can unscrew the base and set it up on a tripod to give the extra height we need. Note that we needed to extend the top tube upwards to get enough clearance, and even then it was pretty tight. The first flights were a big improvement over the last time, but didn't glide very well. It seems that the transition between launch and gliding is the hardest part of getting this working. You need to shift the centre of gravity backwards to be closer to the centre of lift.
3, 2, 1.
About this time, some experiments we did about a year ago popped back up on the internet. We had loosely strapped a glider to the rocket and it worked surprisingly well. So my solution was now to ignore the transition problem and look into separating at apogee. I thought quite a bit about complicated timing mechanisms, but the simplest solution was to get the rocket to tear itself apart using air pressure by attaching the glider and the rocket using Velcro.
Oh yeah.
For this set of tests, we also had the nose cone fall off. This caused a few problems when it wasn't fitted straight or fell off early. Our final tests had the nose cone attached to the booster and we got great results. I estimate we reached in excess of 30 metres. This view from underneath is my favourite and really shows off the stress that the glider goes through. The wings bend straight backwards at one point. This bending also causes it to tumble, which helps with separation. Things to try in the future would be strengthening the wings and maybe adding a parachute to the rocket. I did try using a streamer, but didn't have a good release mechanism. There's definitely room for improvement in the future.